Hello everyone, my name is Aayush. Do you want to create interesting patterns without having to design them by yourself? Here I have an experiment for you. This is called the Chladni Plate. So let's see the materials required. Here, below the foam plate, I have a subwoofer or a speaker. Above that, I have a foam plate which is connected to the subwoofer. The subwoofer is connected to the audio amplifier which plays an online tone using the laptop above. It is running an online tone generator which gives the signal to the audio amplifier. Also, I have some sand here to see the patterns, and this is the reason I am doing this experiment outside. So now let's see the demonstration of this experiment. Here I'll start running a tone of or a frequency of 58 Hz, and first I'll sprinkle some sand over here. The sand is spread equally, and now I'll turn on the volume, and as you can see it forms interesting patterns. Now I'll increase the frequency from the laptop. Here it's 58 Hz. Now I'm going to increase it, and as you can see the pattern on the foam board changes. Let's go further in frequency. I'll keep adding sand. That forms an X. Here I'm controlling the frequency as well as the volume of the speaker. I'll go further. As you can see, now I'm at 225 Hz, and a beautiful pattern has been formed which includes a circle and 4 lines. I'll go further. I'm at 591 Hz. And here I have reached the limit of this system. This system cannot go any further because there is no amplitude left for the speaker to vibrate in. Also, there is a limitation of the speaker as well as the audio amplifier. This cannot output as much power as it needs on such high frequencies. So the basic phenomena behind this is of standing waves. But before understanding what a standing wave is, we first see what a wave is.
In physics, a wave is a disturbance traveling through a medium or through space.
But if I can constrain my medium on the other end, the wave would reflect back. See?
Now if I send continuous waves down the slinky, they will also reflect back, and what I get is two waves, one moving away from me and one moving towards me. But obviously the rope can't be in both places at the same time. So as my incoming wave reflects back, I don't see both the waves. I see only a combination of two. The waves add up when they are on top of each other and subtract when they are opposing each other. and something crazy happens here. Now you have got a wave moving this way combined with another wave moving that way. And when they interfere, the resultant wave is, as you might expect, a wave that doesn't appear to be moving in any direction. And this is called the standing wave. The places where the wave appears to be not moving at all are called nodes, and the places where they move a lot are called antinodes.
Now we know what nodes and antinodes are, but how does that relate to this foam piece? Let's understand. Here, I'll be showing you a cross section of the area of the foam piece, which will be represented by this strip. So I'll remove this and attach this. And I even made this mechanism at home. This is the cup and it has a screw on top, and this is the nut. So let me turn on the frequency from here. Now as you can see, and I'll be showing you a small slow motion clip here.
Here, the parts which move a lot are called the antinodes, and the places which do not move at all are called the nodes. The sand, which is evenly scattered, travels towards the nodes as there isn't any movement or vibration there.
Now let me answer one of your questions. The question I got asked is, why are there more patterns in higher frequencies and less patterns in lower frequencies? As we could see, in 58 Hz there was only a circle, but as I went to around 1600 Hz there were many intricate patterns forming. But how is this possible? Let's come closer here and see. For example, from this length, from the origin of the wave till the end, there is one wavelength. So there will be one node and one antinode forming. But if the frequency is higher, then the wavelength would decrease. And in essence of that, there would be, just as a number, there would be two wavelengths forming here. So there would be two nodes and two antinodes. And as we have two nodes, there would be two places where sand could have rested. And so we have more intricate patterns on higher frequencies. But to show this all, I created another experiment using a stool and a Bluetooth speaker. Because this is a subwoofer, it cannot go higher than around 1600 frequency or hertz. But being a Bluetooth speaker, it could go up to 20k hertz. So let's see that.
So this is my setup. The Bluetooth speaker is connected to the laptop. It is kept in the stool, and the stool is covered by a polythene diaphragm. The speaker vibrates the air inside the stool, which indirectly transfers the vibration to the diaphragm via air. Because the frequency here is very high, starting from 5 kHz or 5000 Hz, the patterns are much more intricate and close together.
So this was all, but during the past month, I came up with different patterns because I used different amplifiers, different speakers, big speakers, small speakers, etc. So I got different patterns, and here is a small slideshow of all the patterns that I got with their respective frequencies. So thank you everyone for watching, and happy tinkering.